7, 8, I'm wrong. 7, 6, 5, 4, 3, 2, 1, 0. Okay, now I'm starting. You did your chats. Now it's time to listen to me. We're going to start integration. Funky business. What did you do in Calc 1 and 2 for integration? Besides crying, you had a little bit of an interval, and you had a curve, right? So what did let's start with when the curve was above x-axis. And I'm going to do that for Calc 3 also. So what did you find? You would have a little interval and little area under the curve, right? What was the notation? A, B, f of x dx. What was the Riemann sum in here? xi star delta x I from 1 to n. And so the story was, it's really, we're increasing number of n, we're increasing n to get that area when that limit exists, right? So now I have, this was function of one variable. Now I have function of two variables. What's going to happen to me? So here is a picture. Function of two variable. What's the graph of function of variable? One curve or a surface? Surface, right? Everybody agrees? Function of two variables, I have a surface. Again, let's assume that everything is above the xy plane. Because when we start with any integral, we start above, positive. So here, surface above xy plane, here, surface above xy plane. If I'm integrating, what do you guys think I'm trying to find? Yeah, but I mean, everything under that surface is a volume, right? So it's area times the height this time. Area times the height. So you're finding a volume. That shape, do you see how random D is? Can everybody see D as a domain in xy plane? That's a random D. That's 15.2. This is my problem today, 15.1, rectangular region, right? The other funky part is that the domain is kind of funky in Calc 3. In Calc 1 and Calc 2, it wasn't. So the two funky things that are going on. So let me write this down. Calc of one variable. Calc of two or more, multivariable. In here, you're trying to find area. Here, you're finding volume, right? In here, you will have a domain that is an interval. Over here, you will have a rectangle for so far. It's going to change. Right, for this part is just a rectangle. What does a rectangle look like? Do you guys know, can you guys guess what rectangle is this? It's a rectangle, but let me see. Here's a rectangle. Can you tell me what is this value and what is this value? A and B. So this part tells you about the x-axis, and that part tells you about the y-axis. and over here is C and D. Right? Later on, it would look like D, like that. But right now, it's just rectangular. This is 15.1, this is 15.2. So you can get multiple shapes. Now, what else do I need to know? I need to know the Riemann sum. Riemann sum here was what? F sub xi star delta x, I goes from 1 to n. How do I do Riemann sum here? Over here, I remember I had an A and B, and I would divide it like this, delta x. They're supposed to be of equal lengths in here. I just couldn't do it. Equal length. Now, what do I do here for the Riemann sum? That's the domain, that's the domain. Squares. So little squares. Or little rectangles, right? So I will have, basically, I will have delta x and delta y for each rectangle, area of each rectangle. Then I have to have a height coming out of this, and that's f of x and y. But I know that I need this to be a chosen point. Well, how do I go? If I sum this over I, I'm just going on one line. I'm sorry, I'm going one line this, one line this way. If I sum it over j, going one line that way. So I have to sum it over I and j. So it's double sum. Then if I want to basically make this closer and closer to the actual volume, I need two limits. And this one only needed one limit. Now, notation. This part was domain. That was meaning notation here was f of x dx. Can you guys see this? A to B. Here you will have double integral over region D, could be rectangular or not, of f of x and y dA of x and y. dA, we will learn very quickly, is either dx dy or dy dx in this course. Fair game? So that's a double integral, that's a single integral, and the story goes on. Now, that you believed me, right? All these stories of you have the y1, x1, x2, and those little intervals. That's a nice picture. I can draw that, but it doesn't look as nicely. So if you're looking at the domain and you basically broke the domain into little pieces, skip. So if you have a little domain, rectangular domain, that doesn't look good. Are these two parallel? They're almost parallel. And then you broke it down into smaller rectangles. Then what I'm looking for is over each small rectangle, there is a prism coming up. Let's try that. Prism. So I'm finding, in the Riemann sum, I'm finding the volume of that prism. And then I'm putting all the prisms together. Each prism, and then you're summing it up. That's why there is a double sum in here, because you're summing it up this way, and then you're summing it up the other way. Make sense? So do you see that prism? ends on the surface. I want to find all the prisms under the surface that end at the surface for some point. It would be a little less or more. Oh, there we go. That's the fun part. Do you see all the prisms now? If I add up all the volumes of the prisms, are they adding up almost to the volume under? Yeah? So how about if I make the base smaller and smaller? It gets closer and closer. It's just like Riemann sum that you did in Calc 1. Fair game? Okay. So let's do one iClicker. If you looked at those, let me tell you one thing before you start the iClicker. When we were doing the prisms over there, each prism had a height. What was the height for each prism? So how did I find the height for each prism? I would find the sample point in a rectangle, base rectangle, and then plug it into the function, original function. So now this question is, so you guys tell me what are the sample points in here. You need one sample point for each little rectangle. What would you say is a sample point? What are you guessing? So you're saying upper right. If I do upper right, does this have a sample point? Yeah, the black dot. The black dots are sample points. The black dots are sample points. So if I go upper right endpoints, does every rectangle have an upper right end? Yes. So that works. But if I would go upper left, does every rectangle have one? No. So this represents the first one? Yeah. Okay. Can I count down? What was the question? Does that make sense? I just want you to look at the presentation and tell me if choose an option that gives you one sample point for each rectangle. And there's only one of them that does that. 4. Remember your left or right. 3, 2, 1, 0. Okay. Who's not listening or who's not in class? I don't know. So now, the next question I want to do is I want to use this Riemann sum approximation. Are you guys ready? I'm going to get there. Just give me a minute. Okay, so the question is asking, oh, I forgot to explain this notation. 2 pages ago, it explains the notation. When I say S4 and 3, meaning divide the interval, let me see, what's the interval for x? 1 and 9. So this is saying S4 and 3 is divide 1 and 9, or the interval for x, into 4. And then that's divide, by the way. Divide. Is that correct? Oh, yeah, that's why. Then divide 0 and 3 into 3 intervals. So what would that be? That's like if let's draw this domain, start from 1, end at 9, start at 0, end at 3. It looks like this. On the x, you divide by 4, right? And then on the y, you divide by 3. And that's the shape. 4 interval, 1, 2, 3, 4. 1, 2, 3. Fair game? So that's the shape. Now it's telling you the first one says upper left point. So this, 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 all of those. Fair game? I'm forgetting those intervals, right? Upper left. Fair game? Okay. So now let's look at the picture that actually is worth looking at, not the one I drew. So these are, wait, upper left. Ignore that picture. Shh. This one. Upper left. Upper left, upper left. Upper left, upper left. All of those. Better? Okay, now let's see, what is that point? That's 1 and 3. This one is 1 and 2, 1 and 1, 3 and 3, 3 and 2, and so on, right? So what you need to do, find the area of each. What is the area of each of these? First of all, let's find delta x and delta y, because delta x and delta y, this is delta x, that is delta y, right? Delta x comes from the upper minus lower, 9 minus 1, upper minus lower, divide by how many? 4. So that's 2. Then delta y is what? The other one. So upper minus lower, 3 minus 0 divided by 3, which is 1. So I get delta x and delta y. Now, delta x, what's the area of a prism? Delta x, delta y times height. And how do I find the height for this first one, for example? Sample point, what is f in here? Okay, so this is something that happens to a lot of us. We get confused what f is. In Calc 1 and Calc 2, f was always the function inside, right? So that's our function. X times y is f of x and y. So for example, when I'm doing delta x, delta y, f of 1 and 3, right, for the first one. F of 1 and 3 is what? 3 times 1. And delta x, delta y, I know is 2. Then I come, let's go over there. Then plus, again, 2 for delta x, delta y, f of 3 and 3, which is 9. And then again, 2 times here is 5 and 3. This one is 7 and 3. So 5 and 3 is what, 15? Is 15 plus 2 times f of 7 and 3, which is, what, 21? 21. Then again, plus, I'm just not writing the f anymore. This is 2 plus 2 times, and this one is 6, and plus 2 times, that one is 5 and 2, so it's 10, and then plus 2 times, it's 5 and 3, which is 15. And then 1 down here is 1, plus 2 times 3, plus 2 times 5, that point, 5 and 1, 2 times 7. Did I make an error in here? I made an error in here. This is supposed to be 14. Andrew, why are you confused? Tell me so I can fix that. I didn't write all the points down, but I figured them out, right? I'm doing all the points. And 3 and 1, and 5 and 1, and 7 and 1. Not Ashley. The other one. Ashley's here. Tell me. Alyssa, thank you. Alyssa, go. Oh, I'm doing, imagine there is a prism right above this. Do not pick on him, Nick. Pick on her, Nick. So there's a prism up here, right? So I'm finding the volume of that prism. First, I found the volume of this prism, then that one, then that one. All of those prisms, I'm adding them up. Oh, you can factor the 2 out, yes. Is that what you're saying? You're saying that factor 2 out and then write 3 plus 9 plus 15. Is that what you're saying? Okay, yes, you can. It was my first time I was trying to explain everything. Won't happen again. And then the answer to that is, the answer to that is 180. Questions so far? Take 10 seconds and discuss it. Do I need to do one more of these or are we good? There's one in the homework. Nick, go. Oh, no, that was the, oh, I'm on the wrong one. I did this one. I did the second one. I apologize. I did the second one. I skipped the first one. Everybody's okay so far? Do I need to go back and do the first one or we're good? Everybody okay? Okay. It's just you find the points, sample points, and you plug in. That's all. Okay. And then you find all the volume of the things, and then you go. Okay. Oh, gosh, dang it. Do you guys want to be stuck doing this forever? No. It wasn't bad. But then you have to make it more and smaller rectangles and painful. Because you want it more accurate. No, but no, you can't. You have to actually do the work. Yeah, I think I swapped these two. I swapped them. Oh, gosh. Oh, my goodness. I listened to what you said, actually. I didn't read it. I listened to what you said. Left, upper left. Upper left. So I had the wrong one in here, and it didn't match the one that I had up on the slides. This was upper left on the slides, and you read that. Nobody complained earlier than that? No? Upper left. Can I continue? Okay, so here's the deal. That is nice and pretty, but we don't want to do it this way because then I have to make it smaller and smaller rectangle and compute, right? It doesn't work that way. So what's the next best thing? Next best thing is that let's try to slice into very thin. Can you see this? Slice into very thin volumes. compute each slice, then take the integral, adding all the volumes, adding all the slices. So one integral computes thin volume, the other integral adds them all up. Do you see this? All those slices. I can go either this direction, add all those slices, or I can go the other direction, add all those slices. One thing I want to notice, is this slice bigger volume, or is the next one bigger volume? Or is this the bigger volume? First one was bigger, so the volume changes per slice. So I have to compute each slice. Say again? Yep. Let me remind you, somebody yelled at, this is upper left, and I didn't read this. I just did what they asked me to. Okay, so what is happening here is this. I have this region sitting here. Come on, guys. And then let's say this is x. So I fix an x value. And I take a very small delta x. And then I go on the volume, and so it's small delta x. Delta x. So delta x becomes your height. Come on. Delta x becomes your height, and the area becomes your base. So you compute that. But how do I find the area over here if x is fixed? Integral of f of x and y with respect to y. And you guys know that goes from C to D. This gives me the volume of, this gives me the area of base of this slice. Right? And then I have to add all these slices, right? Multiply by delta x, right? I have to multiply by delta x. I'm writing it as dx, and I go A to B. So I find the area, then I find the outer one. Both of these integrals are calc. One integral is just with x and y sitting there. One of them is going to be constant. That's a pretty part of it. Now, the same thing that I did here, I can do the opposite. I can fix the y and take the integral with respect to x first. Then take the integral with respect to y. And that's, again, you do. Repeat after me. Every time you do an inner integral first, inner integral. Say inner integral. Thank you. That's the first one. Then you do an outer integral. And so no more of that remains some stuff, basically. Oh, if I slice it this way or slice it the other way, should I get the same answer? Yes. That is called Fubini theorem. Fubini. Fubini? So Fubini's theorem. Funnily enough, because I have an accent, sometimes I actually say the names better than everybody else because I actually know how to pronounce them. Not every time. Sometimes I say things funkily, but like no. So funkily. So for the if f is continuous on this region, then integral x equal to a, x equal to b, f of x and y dx. Then dy, y equal to c, y equal to d is equal to inner this time, y equal to c, y equal to d, f of x and y dy, then dx. So you can switch the sides. Quick question. What was the bounds for x in here? A and B. Look at this. Where do you see the bounds for x? Inner or outer for this one? Inner. Because these two match these two. Then you see those bounds for y, the outer. Over here also. Bounds match y, then match x. Are you guys ready to answer a question about this? Okay, do it. First of all, recognize what are the bounds for it. What are the bounds for y in the original? Bounds for y in the original. Inner bounds. 1 and 5. What are the bounds for x? 3 and 4. I always go from small to big. Now, which one x is 3, 4? Y is 1 and 5. Okay. Did everybody get that? We're good? Can I count down? Everybody's sassy today. I don't know what's going on. It started with Fabini. Yeah, I had this discussion with one of the grad students. There is a better chance that I pronounce the names better. Do not trust me on other things, but on the names, just. Okay, can I stop? 4, 3, 2, 1, 0. Yes. How? Okay, so now I'm going to do a bunch of questions, and then I do an iClicker after that. So this story tells me that I can find an integral. What do you guys choose to be an integral? Choose something. Y. So I'm going to do, what is the bounds for y? 0, 1. What is f? dy. Okay, pay a little attention here. 1 is a constant. What is the integral with respect to y? X is a constant. What is the integral with respect to y? 2y is, 2 is the constant coefficient, but y, so what is the integral of that? And then what do I put in? Yes, 2 gets canceled, thank you. And now plug it in, what do I get? I get 2 plus x, right? Plug in for y, you have to plug in. Remember, this is y. Yeah, it's the opposite of the partial derivative, right? It's opposite of the partial derivative. Now, this is my inner integral. This is my inner integral. You compute it. Now I have an outer integral with respect to x. Goes from 0 to 1. And this was supposed to be what? 2 plus x. So for the outer one, I didn't have to worry about another variable. It was just x. For the inner one, I had to. worry about another variable. So this becomes 2x plus, and I get what? 2 plus 1/2, which is 5/2. Okay. Do you guys trust me, or do you want me to do the other way? Fubini way. Trust you? So, Hope, what is the question? Oh, trust me or not? Yeah, you raise your hand. What's that? Oh, yeah, because when I was evaluating with respect to y, I had to plug in y equal to 1 and then y equal to 0. Good question. What's that? Oh, yeah, you have 1 plus 1 plus, yes. So the other direction, you would get the same number. You can try it. This called, by the way, this method is called iterated integral. I forgot to say that when I said Fubini. Iterated. There's an iteration, this way or that way. Yeah. So I could go with dx first, 0, 1, 0, 1 dy. What? You believe me? But I mean quickly. This is the shape that you see and I ask you to evaluate. You have to circle the middle one, compute the middle one, then start it. Inner is the first. And you get 0 to 1. And then you end up with, when you plug in 1 for x, you get 3/2 plus 2y. And then you compute and you get 5/2. Okay. Thank you for trusting in me. Now I'm going to do something very funky, and at the end of the class I'm going to ask you about it. Funky business starting right now. Which direction? X or y first? X first. X squared y dx. X runs from what to what? 0 to 2. See, I always write the inner first. Have that habit. Inner first. Then do the outer. You're okay, Andrew? dy goes from what to what? Okay. Now I'm going to do something funky. Wait a minute. Look at this inner. X is the variable. What is y with respect to x? Well, do you guys remember I used to bring the constant out? Can I do that now? So y came out. What is left? Oh, fun. One quick question. What is this when I evaluate? When I evaluate this, would it have variable or is it constant? Everybody agrees this is constant. What I circled? Constant, right? Oh, can constant come out of the integral? Let's take it out. That's a constant, right? What are you left with? What just happened? I separated the two integrals. Thank you, Noah. So I separated the two integrals. The reason I could do it was that I had a function of x only multiply a function of y only. Look at this one. I could not factor this into function of x only and y only. But over there, I have a function of x only multiplied by a function of y only. function of x only times function of 1, a function of and that's the only time you can separate them. Now it's easier than even what we had before. Fair game? You can compute each one of those, which is x to the third over 3, 0 to 2, and y squared over 2, 1 to 3. And you guys compute this and tell me what the answer is. Where's my clicker? Are you my guardian? And the answer to this one is 32 over 2. So when can I split the double integral? Function of x only, function of y only, dA of x and y over the region, rectangular region. Non-rectangular region causes a little bit of problem also. So you can write it as a to b of f of x dx times c to d of g of y dy. Function of x only, factors are function of x only and function of y only. I do enjoy that you're enjoying the class so much, but sometimes please let my voice be heard. Okay. Now, my friends, here's the thing. Do you guys think I always should do one way or another, or sometimes I have to try? Let's try. Here's the thing. Let's set this up as dx first. And let's try to not cry as much. Okay, which integral am I computing first? X. How do I find that? Give me a method now. Wait, if it's e to the x times e to the y, it's like that. All right, so I can't do that. That's the problem. What is the method? Somebody said it. Integration by parts. Are you guys up to it? So what should I do? Swap? Let's swap this. Is this easier to do? Yes, what is the integral here? It's x comes out, integral 1 to 2, e to the xy dy dx. So what is that integral inside? X is the coefficient of the exponent. So this is going to be e to the power xy divided by x, 0 to 2, and x is here, so they simplify. Then plug in 2 for y. These two simplify. So e to the 2x minus e to the 0, which is what? What do I do? It's from 1 to 2. Thank you. Oh, man. That was bad. I'm sorry. So e to the x dx. And then you integrate that, and it's going to be, and I want to give you one more iClicker. Give me a minute. E to the 2x divided by 2 minus e to the x, 0 to 2, and the answer is, who knows? It's if I plug in 2, I get e to the 4 divided by 2 minus e to the 4, then minus e to the 0 divided by 2 minus, which is 1, minus 1, and you get e to the 4 divided by 2 minus e squared plus 1/2. Fair game? Okay. So that was the story. Sometimes it matters if you choose one way or another. Did you break it? Okay. By the way, one of the Lagrange multipliers moved, one of the examples of the lecture moved to the lab on Wednesday or Thursday. One of the examples moved to lab. I'm letting you out in 2 minutes. Okay, first question, can I separate? Can I separate y? Function of x only times function of y only. Factors are x only and y only. Separation we can do, right? What else do we need to figure out? The second one is saying that, is that equal to 0? And here's my hint. Switch the order in the second one and tell me if the inner function is 0. Switch the order. Switch the order in 2. Switch the order. What do you get? No. If I switch the order in the second one, what do I get? What's the inner function in the second one if I switch the order? Okay, let's not put it that way. Separate the second one. What do I get with respect to y? What is sine? Is it odd or even function or nothing? Cosine is even, sine is odd. You get 0 by symmetry. Yeah, by symmetry, right? C? I think it's C. Okay, so anybody has argument against C? Speak up now. We're good? No? Okay, I'm going to go stop it. What? I don't know. 4, 3, 2, 1, 0. Hey, sorry for being late. Good. How are you? Oh, I'm sorry. Yeah, I can turn that on so you can remove your mask. Yes. Oh. Did it work or not? Send me an email. Send me an email, I'll replace it. Yes?
I wasn't paying attention to my phone for a second before I got here. My phone just died before I came up. I wrote down all the questions, but I don't know if it'll...
Send me right now, send me an email. Don't do that again. Oh, James.
During office hours on Wednesday, will you rate that?
Sure, you can come in. Oh, we haven't done it yet. Have we done it? We've done it once.
We've done one grade check this semester.
Office hours Wednesday is good. Hey, what's up? Should I leave this? I don't know if they needed. We have better pictures for slicing. So, yeah. Hey.
I was looking at possible schedules for next semester, and I was wondering if it would